Hello all, and thank you for joining this webinar, Sustainability and You, How Evoqua Can Help. My name is Quinn Moss, and I'm the Digital Business Developer for Evoqua's Municipal Services Division, and I'll be guiding you through this presentation today. Sustainability has been a part of providing water for many years, from the Clean Water Act to asset management. However, it's risen to new importance as we're facing new operational challenges, such as extreme weather, water scarcity, quality issues, emerging contaminants, and so forth, and facing those challenges with less labor and more difficult to acquire funding. Folding in sustainability into your operations in a broader way than ever before will make you more efficient and resilient, your community safer, and your stakeholders happier. As you can see here from the 2022 Black & Veatch report, when municipal utilities consider sustainability, they think of a wide variety of activities and topics, from infrastructure and asset management to, call it, traditional sustainability actions like water conservation and utilizing green energy, to brand new technologies like reuse and nutrient removal. Municipalities are taking action, but no one can do it alone. Today, we're going to talk about the ESG model of sustainability and walk through some specific sustainability topics that are applying more and more to water utilities. Finally, we'll discuss how Evoqua can help you meet your sustainability goals. So let's get started. The ESG model of sustainability is a holistic approach that takes into account not only the planet, but also the people. You'll see here ESG, environmental, social, and governance. While environmental topics that focus on maintaining the health of the natural world are synonymous for many to sustainability, the picture is much broader now. Social sustainability focuses on relationships between companies, communities, and government, and how they influence our ability to operate into the future. And as a water utility, you're very intimately familiar with governance, which describes how we can utilize policy and procedure to conduct our work ethically and responsibly. This model broadens the scope beyond just the environment and looks at how people and systems fit into the picture. But I'm sure many of you are wondering, okay, I understand these basic definitions, but what are we talking about specifically? So let's go from conceptual to tactical. Let's walk through a small set of examples of key ESG topics under each category that are relevant to water utilities. I won't belabor the point on environmental. I think most, if not all, of these terms are ones that you've at least heard of before, from emerging contaminants to water scarcity. When we look to social, health and safety has been part of the picture for many years. But there are new topics like diversity, resilience, equity, and water justice that have more recently taken the spotlight, and yet can still have a significant impact on a utility's operation and goals. And finally, the examples of applicable governance topics should still be very familiar to you, all the way from infrastructure to regulatory compliance. The ESG model isn't complicated, but it gives us a great framework for understanding the work to be done. And there's so much to discuss with sustainability. Even this select list is pretty long. And if we went through everything, we would be here all day. So we're going to focus on the following set of topics. These topics of focus for today were selected because we've seen them mentioned at conferences, in industry publications, or as part of our discussions we have every day with utilities. Again, given our limited time here today, we had to make some decisions and focus in on our discussion. But if there are any topics that you'd like to touch on with our team, our contact information will be at the end of the presentation. With that, let's dive in. Our first topic is one that many are familiar with and associate pretty strongly with sustainability, and that's energy use and sources. This has been part of the conversation since the early days of the modern sustainability movement, and really the average person is probably aware of the progress we've been making on some level. You can see here that over the past 20 years, there have been significant shifts in how energy is generated, with a reduced reliance on coal and a larger utilization of natural gas and other renewables, which is non-hydroelectric and non-nuclear methods like wind turbines or solar. But why have we made this shift? It's because the environmental effects are real. From greenhouse gas emissions, which we'll talk about soon, to water usage, waste generation, and frankly, the overall effects on the ecosystem, including pollution, energy generation has a significant impact on the world around us. While the water industry is not in the business of selling energy, we certainly do use plenty of it, and the energy that we use is an important part of a municipality's overall sustainability picture. So what are the numbers for energy in the context of municipal water? As you can see here, 2% of overall US electricity use is from drinking water and wastewater systems. That's pretty enormous that we can measure that on the scale of the entire country. Then it is unsurprising that up to 40% of operating costs for drinking water systems can be just energy. So with that amount of spend on energy, there's also a pretty significant opportunity for savings. So 15 to 30% savings on energy spend can be achieved through efficiency practices. This shows that there are not only environmental upside to choosing your energy sources and managing your energy usage, but also financial upsides at the utility level. So with this grounding in energy use and generation, we're going to hop back to a key word that I've mentioned briefly, which is greenhouse gases. Greenhouse gases are closely associated with discussions about energy, given that some energy sources are major emitters of this category of gases. But GHGs are a different and distinct topic from energy itself. Globally, water utilities emit the same volume of greenhouse gases as the world's global maritime shipping industry. And it's not just greenhouse gases associated with energy. For utilities, methanol carbon dioxide and sewer methane generation, plus process or effluent nitrous oxide, are water and wastewater specific emissions and unique challenges to utilities. But why do these greenhouse gases, which include carbon dioxide, methane, nitrous oxide, and fluorinated gases, matter? They matter because their emissions accelerate global warming, and pretty much everybody and every industry emits some amount of greenhouse gases. However, not all of these gases are created equal, and we utilize CO2e, which is CO2 equivalency, also known as the GWP or global warming potential, to create a comparative understanding of the impacts of these different gases. So in the table on the bottom right-hand corner, you can see those different values to put some scope to the impacts between these. Basically, the CO2e value is calculated based on the number of metric tons of CO2 that would have an equivalent impact over 100 years as the comparative gas. So, for example, 1 metric ton of methane has the same impact as 28 metric tons of CO2e. This means that we do have to analyze and prioritize our management of greenhouse gas emissions in order to slow global warming. When we talk about greenhouse gases, sustainability professionals use a scope categorization to break down the sources of emissions connected to a group. Scope 1 emissions are ones that are a direct result of that subject's activities. For example, sewer methane emission is a Scope 1 emission for a wastewater utility. Scope 2 always describes the emissions from the energy sources used by the subject. And Scope 3 describes indirect emissions, such as the car emissions generated by water utility employees as they drive to work every day. Why do these scopes matter? Why do we break it down in this way? Well, you have a different level of control over each scope, but you are accountable for all of them. That accountability can come in the form of a net zero commitment, which is also sometimes called decarbonization, greenhouse gas emissions reduction, etc. This commitment says that the subject will have effectively zero greenhouse gas emissions impact on the environment, which is achieved through both emission reduction and offset. Thus far, one U.S. utility has made a net zero commitment, but 104 U.S. cities have, which will very likely impact their associated utilities. The discussions around greenhouse gases and the prioritization of understanding and reducing them is gaining momentum in the water industry. And being aware of your individual sources and impact will become increasingly important for you, regardless of if you have made a net zero commitment. Let's discuss another hot topic, emerging contaminants. As I'm sure you all very well know, emerging contaminants are constituents that are measurably present in water today, may result in human or environmental health effects, and are currently unregulated. While we are now on the path towards regulation, these new contaminants are still much less studied and understood due to the relative recency of their emergence. This list that we have here is far from an exhaustive list of emerging contaminants, but it does contain a selection of some of the most discussed contaminants, where they're used, their health effects, and the screening levels that we've established thus far. As you can see, emerging contaminants come from a pretty wide variety of sources, from our friend the oft talked about nonstick pan to deodorant and rocket fuel. And they can have a variety of effects on humans, from being carcinogenic to resulting in immune or thyroid disruption. As a water utility, finding a path forward on emerging contaminants while regulations are developed is a major sustainability challenge. And then, as regulations are put into effect and these contaminants move out of the emerging contaminants area, there are additional challenges there to meet the requirements. When we talk about wastewater, there's an interesting implication in the name, that it's waste or something that cannot be used and must be disposed of. But in a world focused on sustainability, and particularly on conserving precious resources, wastewater is no longer just waste. First off, also in the name, wastewater contains, you guessed it, water. This water can be extracted using potable reuse methods, either indirect or direct, or utilized in agricultural settings. Also on the agricultural side, the biosolids in wastewater can be extracted and reused as fertilizer. Back to our discussion about energy, there is plenty of energy trapped in that wastewater, be it biogas, biohydrogen, or just recovering the heat of the wastewater as it comes in. These all are great clean energy sources that, in the case of biogas, also utilize the greenhouse gases instead of letting them escape and affect the atmosphere. So kind of a 2-for-1 deal there in terms of positive benefit. And finally, there are plenty of nutrients in wastewater that can be captured and sold for reuse. Shifting our mindset away from waste and towards resources with wastewater is a really exciting sustainability challenge. I don't think we'll be spending a lot of time on this next topic today. As water professionals, we are all acutely aware of the rise of water scarcity across the nation, either due to the general lack of water or the lack of specifically quality water. Managing this precious resource is one of the water utility's oldest responsibilities, and unfortunately, the challenge has only become greater in the modern day. Solutions to water scarcity are not solely for the utility to solve, but utilities are a key player in the path forward. Water scarcity is so big that it's even a topic we see in the news. For example, in May of 2023, Arizona, Nevada, and California came to an agreement to reduce withdrawals from the Colorado River to the tune of 3 million acre-feet. While this example is not the first or last conversation about water scarcity, I think it really signals the importance of the topic and the wide-reaching discussions already being had about it. While we may not directly think of ecosystem protection as part of sustainability for water utilities, there are plenty of opportunities for utilities to make the difference here as well. Protecting riparian zones, watersheds, and oceans by managing discharge, biology, and overall water quality is a pretty direct way for utilities to engage in ecosystem protection. But even on the more traditional side of ecosystem management, like habitat and landscape conservation, there are plenty of opportunities to enhance the world around you. Let's take a step back from environmental topics and move into social. Water justice is a newer player in the sustainability field. There's a pretty wide variety of definitions out there, as it is so new, but here's the one we stick with at Evoqua. Water justice is the use of democratic water policies and sustainable development practices to promote equitable water distribution. What does this mean in practice? Well, achieving water justice happens through a wide variety of activities. Ensuring equal access to high quality water through good distribution systems for all is a pretty strong foundation. And then we can add to that fair management of the water and the utility and safety from byproducts. Achieving water justice doesn't happen in a vacuum, and utilities, local government, and the community must work together to achieve democratic, sustainable, and equitable water for all, which is what makes this topic a part of the sustainability aspect of ESG. And for our final sustainability topic of the day, we enter governance to discuss an area of, again, some pretty strong focus, much like water scarcity. But this one is infrastructure condition and investment. As mentioned, like water scarcity, this is one that's no surprise to any water industry professional, and a great many utilities are already neck deep. After all, this is no small problem. With over 150,000 drinking water treatment systems and 16,000 wastewater treatment systems, plus 3.5 million miles of pipe for either drinking water or wastewater, there is a lot of infrastructure to look after. And there are so many factors that can affect its condition. Everything from wastewater byproducts like hydrogen sulfide or fog, to extreme weather and a lack of visibility into the system can impact the infrastructure condition. And one of the greatest impacts on infrastructure condition happens outside of the plants and pipes. Funding is a challenge that every utility faces. When it comes to capital dollars spent on infrastructure, federal funding of water and wastewater infrastructure has dropped from 63% 40 years ago to 9% now. This means that an estimated funding gap of $430 million will emerge by 2029, even as the crisis continues to evolve and conditions continue to degrade. Utilities can't sustain their operations without infrastructure, and high-quality infrastructure can impact many of the topics we've discussed today. So in some ways, it truly is a cornerstone of a utility's sustainability journey. With our quick journey through sustainability for utilities, we've discussed a pretty wide variety of different challenges. Not an exhaustive list, but a good taste of all of the different directions that we have to think under an ESG model of sustainability. But how can we sum it all up? I've been very lucky to have the opportunity to speak with a variety of utilities about sustainability and what sustainability means to them. I think it boils down pretty well to this quote. It's about the sustainability of my business. What do I need to do today to successfully operate over the next 100 years? While 100 years may feel like a very ambitious timescale when we have so many challenges to wrangle today, it does give utilities the opportunity to step back and think about the long-term impacts and what they can do today to ensure their communities have access to safe and affordable water for a very long time to come. So as mentioned, there's a lot you can do to engage in sustainability today and prepare for it in the future, and Evoqua is here to help. Much like the first part of this presentation, this will not be an exhaustive discussion of our sustainability solutions, but it can give you a first taste of how we can support you. We're going to focus on three main solutions today: BIOXIDE, vapor phase odor control, and specifically biotrickling filters, and emerging contaminants technologies. For each of these three solutions, you can see on this slide a high-level summary of how they can be used to support many of the sustainability topics we discussed today. Common across all of these solutions are water justice, health and safety, and regulatory compliance. In addition to those broad themes, BIOXIDE is able to positively impact infrastructure condition and greenhouse gas emissions. Biotrickling filters can assist in water management, and emerging contaminant solutions broadly positively impact your community and ecosystem. So with this high-level summary in mind, let's dive a little deeper into some key topics on each solution. First up is the BIOXIDE solution. As shared at the WEF Odor and Air Pollutants Conference by my colleague Danielle Arney, Evoqua has been doing a study to understand the impact of BIOXIDE dosing on greenhouse gas emissions. So to take a quick step back, the BIOXIDE solution works by interrupting the sewer sulfide cycle to reduce H2S emissions. But as it turns out, there could be another beneficial effect that we weren't expecting. The two chemical equations on the upper right demonstrate theoretically that in an untreated state, both methane and CO2 are emitted as part of hydrogen sulfide generation, whereas in a treated state, more carbon dioxide is emitted, but no methane emitted. As we think all the way back to the beginning of this presentation and to our CO2e or global warming potential values, we'll remember that methane has 28 times the effect that carbon dioxide does. So even though we're seeing a little bit more carbon dioxide emission, that elimination of methane results in a significant net GHG reduction. Having said that, right, we're looking at the theoretical here. Sewers are very chemically complicated places, so we need to bridge the gap between the theoretical and the real. And that's where Danielle's study comes in. As you can see in this chart, during the study, which was done at a Southwest Florida utility, we did see measurable reductions in methane emissions when a sewer was in a treated state versus untreated. We are definitely in the early stages of exploring the impact of BIOXIDE solution treatment on sewers, and so we will be continuing this study. But if you missed us at ONAP and would like to learn more, please reach out to me and I can help get you connected. Going back to the more traditional benefits of the BIOXIDE solution, its ability to reduce hydrogen sulfide emissions also has a positive impact on infrastructure condition, which we're going to talk about in the context of reducing concrete corrosion. In a study that we did with the Sanitation District Number 1 of Northern Kentucky, concrete test samples were deployed for 2 full years at the discharges of 2 force mains that had similar potential for sulfide generation and hydrogen sulfide release. The difference between the two was that one force main was treated with BIOXIDE solution and the other was left untreated. At the end of the study, 2 years later, the sample in the untreated main was exposed to an average of 68.5 parts per million of hydrogen sulfide, which resulted in a 5.4% loss of mass and a 13% loss of strength. On the flip side, the sample from the treated site was exposed to an average of 3.6 parts per million in comparison to 68.5, which resulted in a 0.2% reduction in mass and actually a 9% increase in compressive strength. This study demonstrates the utility of the BIOXIDE solution not only as an odor control tool, but as one to help extend the life of your infrastructure. Let's pivot to another solution for odor control, vapor phase solutions. We'll be discussing biotrickling filters specifically. As probably many of you are aware, these filters utilize makeup water to maintain an optimal pH for treatment. And as a result, they can consume anywhere from 14,000 gallons per day for smaller units up to 30,000 gallons per day for larger units, and honestly, even above that in some cases, which not only can work contrary to a utility's water usage goals, it can also add cost to their operations. Neither of those are super awesome. So Evoqua has conducted a study around the use of alkaline materials to neutralize part of the sulfuric acid produced during operation with the goal of reducing water usage. So in the study shown here, we utilized a biotrickling filter that was equipped with a fuzzy logic pH controller, basically the ability to make intelligent decisions, and treated it with a 50% caustic soda of sodium hydroxide. What we saw as a result here was water use reduction from 17 gallons per minute on average to 5 gallons per minute on average, which is a 70% reduction. And that is shown here in the charts, right? The highlighted section there is when the fuzzy logic controller and alkaline solution were being used. So not only is this approach really great for meeting sustainability goals, it's great for meeting your financial goals, all while still ensuring that your community doesn't have to experience odor. The final sustainability solution we'll discuss today is emerging contaminants. So as we mentioned earlier, there's a wide variety of chemicals that fall under the emerging contaminants umbrella. One of the most often talked about contaminants is the family known as PFAS. The EPA has released proposed rules to designate two PFAS, specifically PFOA and PFOS, as hazardous substances under CERCLA. They've also proposed rules for maximum contaminant levels, also known as MCLs, for both PFOA and PFOS, in addition to a combined hazard index for 4 different chemicals: PFNA, PFHS, PFBS, and GenX chemicals. While these are still proposals today, enforcement will likely be arriving in the next 5 years, and utilities can do a lot today to prepare for that future. They can also do a lot today to help their communities feel more informed and safer around emerging contaminants. Evoqua can provide you with a variety of technologies for PFAS removal, including an assortment of different media and both permanent and temporary solutions. And not only that, we can provide expertise to help you choose the right solution for your community. Managing emerging contaminants is a cornerstone to any sustainability plan to protect the health and safety of your community. With that, we've concluded the highlight tour of Evoqua solutions that can support your sustainability goals. As I mentioned before, this is not an exhaustive list. So if there are sustainability goals or solutions that we haven't mentioned today that you are interested in, we are more than happy to discuss how we can help you solve those challenges. Feel free to reach out myself, Quinn Moss, for any questions about this presentation, the methane study, or general sustainability topics. For odor control, contact Joost Goostens, and for emerging contaminants, please contact Jeff Palacia. Thank you so much for joining us today for this discussion about sustainability and water. We really hope that it was an educational review of sustainability as it relates to water utilities and how Evoqua can help you meet your sustainability goals.